In this video, we're going to be tackling quadratic sequences, and we're building on the work of the nth term from previously. Okay, so we need that information to be really solid before we try to attack the quadratic versions. So, nth term, what did we used to do? We looked at the difference between these terms, and here we go plus 7. This one is plus 9, plus 11, and plus 13. So we can see that it's not like the nth term before, where this would go up the same each time. For a quadratic sequence, we do the second difference. And here, these are both going up, or all going up in 2s. So this is how we progress from the nth term to quadratics. We do the second difference. And this number here is very important, this plus 2. Okay, that number there, we always halve it. Okay, whatever that second difference is, we divide it by 2. In this case, it's a 2, so when we divide it by 2, that will just become 1. And whatever that number is, in this case, it's a 1, that becomes our n squared term. Okay, so if this went up in 4s, when we halve it, that would be 2 and then n squared. Every GCSE that's been before, it's either been a 1 or a 2, so they could change that, but it's nearly always 1n squared or 2n squared, depending on the second difference. Okay, so we know that n squared is part of this sequence. So we're going to subtract n squared from our sequence. When we subtract this term, we're always left with a normal nth term sequence. Okay, so it's almost like we've added on this n squared difficulty, so we just subtract it and carry on with our normal nth term sequence work. So n equals 1 for the first term, so 1 squared, 2 squared, 3 squared, 4 squared, and 5 squared, because this is n equals 1, 2, 3, 4, 5. Fifth position, n equals 5. Okay, let's do our subtraction. 7 take away 1, 14 take away 4, 23 take away 9, 34 take away 16, 18, and 47 take away 25 is 22. Okay, so by subtracting that n squared, we're left with a new sequence, and we just start now doing nth term on this. Pretend that all of this is not there, okay? All of that stuff that we just did was to find the n squared part and then to create this new sequence. So just pretend you're doing nth term on this now. So if that none of that stuff it matters here, we're going up in plus 4s, plus 4, 4, 4. So, oops, plus 4. So that would be 4n. I mean positive 4n, so like I'll just put that there. Positive 4n would give me 4, 8, 12, 16, and 20. And then we ask ourselves, how do we get from 4n to here? We plus 2. If any of that I just did was too quick, go back to the nth term work and practice how to generate the nth term. But I'm going to assume that that's solid so that we can just add on this n squared part. So the 4n plus 2 is this red sequence. And then all we do is combine these to get our final quadratic sequence. N squared. Positive 4n, that's why I left a little plus there, but plus 4n and plus 2 should be our sequence that we started with all the way back here. Okay, so I'm not 100% confident I got that correct. So let's go to our calculator and go to the table function. The table function we usually use for graphs, but we can also use it to check our nth terms and our quadratic sequences. So I'm going to put in n squared, I have to use x, 4x plus 2. Ignore that one. Start at 1, end in 5. That works perfectly for my sequence. 7, 14, 23, 34, and 47. So I know that this sequence gives me this pattern of numbers. Okay, so just to recap, we do the first difference like we always do. Quadratics have a squared in them, and they will tell you in the question it's a quadratic sequence. But if they didn't, we can see it's going 7, 9, 11, and the second difference is consistent. So that's what defines a quadratic sequence, a second difference that is the same. We halve it, that becomes our n squared term. Then we subtract n squared, leaving us with a normal nth term sequence, which we work out 4n plus 2, and we tack that onto the end of our n squared part.